Marty, you made it.
Yeah.
Welcome to my latest experiment. This is the big one, the one I've been waiting for all my life.
Well, it's a DeLorean, right?
Bear with me, Marty. All your questions will be answered. My calculations are correct. When this baby hits 88 miles per hour, you're gonna see some serious shit.
Wait. Great Scott, Marty, what do you want? So, I understand the whole time travel and the bending of the space-time continuum, but how does the car actually get up to 88 miles an hour?
Oh, simple. It's just a system of mass and energy balances. Come with me, Marty, I'll show you. So you see, Marty, every mass and energy balance starts with defining a system. In our case, the system is the car itself. Now, gasoline enters the car along with air. So we'll draw two arrows, gasoline and air. Now, these two go into the engine, and the engine creates a certain chemical reaction which produces energy, and that energy is in the form of heat and work shaft.
So I understand how the gasoline turns into energy, but you called this a energy balance, so where's the balance here?
Really, Marty? That's the simplest part. I expected so much more from you. A balance can be split into two, a mass balance and an energy balance, but we have to remember the most important rule. What goes in must come out.
Oh, like the law of conservation of mass and the first law of thermodynamics. So mass and energy aren't created or destroyed, but rather converted.
Well, yeah, if you want to get all technical about it. So the balance starts with this equation right here. Now this is the mass balance. Now let's consider a balance around all the components in the system put together. So total mass, like you said, cannot be created, so we'll get rid of this generation term right here, get rid of the consumption because it can't be destroyed here, and we'll assume it's at steady state, so the accumulation term goes to zero as well. So that simplifies the mass balance down to in equals out. And if we account for that in our diagram for the car, these guys right here just leave the system as exhaust. That's why cars have an exhaust pipe. And if you want to get all technical about it, this is the reaction for the gas inside the car.
But what about the balance, Doc?
Great Scott, Marty. I was going to get to that. This is the energy balance right here. Now we have the terms delta U equals Q plus W. Now we know that Q is heat and W is work, which makes the car move. But what is this delta U right here? Well, what a great question. You see, our exhaust up here has a certain internal energy right here, whereas the gasoline and the air have its own internal energy. Now, if we have delta U, which is the change in internal energy, equals U2 minus U1, that will be the change in internal energy. Now, the products have a lower energy than the reactants, so that means this term will be negative. And if we come to our energy balance right here, this means that the system will be releasing heat and also releasing work.
But where does it all go, Doc?
So to recap, the air and gasoline enter the car, and they leave as exhaust so that a pressurized explosion doesn't happen within the car. Thus, Einstein's molecular structure stays intact. And the exhaust has its own internal energy, and so do the things entering the car. Now, the difference between these two internal energies is the energy that is leaving the car. Thus, the car drives and gets to 88 miles per hour.